All right, so we'll go through 270 exam question. So it's one of the exam question, and we'll get to understand it. All right. So without even wasting it, shall we start? Okay. So 10 moles of an ideal gas expands isothermally and irreversibly from a pressure of 10. All right, from a pressure of 10 atm to a pressure of 2 atm at 300 Kelvin. What is the largest mass which can be lifted through a height of what? 1 meter in this expansion. So, in short, what you need to know is that wherever a volume and the pressure is involved, the work will be done by that system. So, what we do is we are going to say if you put more pressure on this one, there will be a work done, right? Again, when you just expand this gas, you allow it to expand, again some work will be done. So there will be change in volume and also change in pressure. All right, so it will act it will cause work of that system. So what you need to know that here there was change in pressure. So there are two formulas to find work. All right, um there are two formulas to find work due to change in pressure and due to change in volume. So, in general, work is equal to negative pressure, then change in volume. We know this, but they will have a situation whereby even pressure will be changing, and we'll be here to explain that. So, what we'll do is we'll say work in a case of change in whereby you are changing in volume, you say negative RT. Okay, we'll get to know this gas constant. Then you put natural log of change in volume of final volume over change over the initial volume, like that. Okay, so it's one way of finding work. Again, in terms of pressure change, we'll say work is equal to negative RT. All right, natural log of pressure 2. Now in this case we'll put pressure 1 over pressure 2, like that. So this is just a that's why these guys, they are inverse of each other. That's the reason from Boyle's law. So sometimes we can write these formulas negative. All right, you just maintain this one negative in a case of where you want to use logarithm. So you put negative 2.0303. All right, then you put now log, but before you put log, you say RT. Okay, this very simply means just it has changed to log. So you put RT there. Okay, then you put log, then volume 2 over volume 1. Okay, but for pressure, again, you can say is equal to negative 2.0303. All right, log P1. All right, over pressure 2. So now that it was changing in pressure, so we'll go direct and use this one. So hope that is clear. So we just want to find the way. From there we'll be able to see that this thing is actually is isothermally, meaning it was constant, and something which is constant is not changing, so it is at rest, and we use the potential energy formula to find some masses. All right, so what we'll do is I'll say I'll use this formula to say work is equal to I'll punch there. I'll use log or just natural, but let me just put log. But I've forgotten here. You need to put these guys RT. All right. So you multiply RT there. So what I'm going to do here is I'll use that one, this one, to say negative 2.0303. All right. Then RT. All right. I'll use log. All right. I'll use log, or let me just use the first formula. I like the first formula than the um I like the first formula than putting this. So I don't want to press a lot of things on my calculator. All right. So I'll put the other one for, but due to change in pressure. So I'm using this one, but this one. So I'll say RT, natural log of pressure 1 over pressure 2. Okay. So this one, they are always in proper ratio like that. So I'll put now negative what is the gas constant? This gas constant is actually always given, but I'll tell you to say it's for the terms of joules, it's 8.314. All right. Then joules over the same thing, you just put the units, you put kilo more. Okay. Then the temperature now is what is already in Kelvin. So that is 300 Kelvin. All right. So the Kelvin and Kelvin, I'm sure you can see it can go. Then open bracket. Then we'll put natural log of pressure one is what? Pressure one is okay. So pressure one is 10. Okay. So we are putting pressure 1, 10, then pressure 2 to be you put 2 there. Okay. So from there you just punch now on your calculator. So let's punch. Okay, so we punch. Okay, let's punch. So that will be negative 8.314 times 300, right? Then, okay. So the answer there, I'll say, is now negative 94.2. Then natural log of what is the pressure now? The pressure is 10, right? Okay. So the pressure is now 10. So you put, we can just say 5, natural log of 5. Then times, okay, natural log, you punch on your calculator. So that will give us, it's giving me, I don't know with my calculator, but it's not supposed to give me this value. So it's giving me 40, negative 40, all right, negative 40, 4.2, then 60041. So I'll move this point, I can move 1, 2, 3. So I'll have negative 4 point, okay, negative 4 point times, or let me just do this. Okay. So I don't know, you can verify with your calculator. So this will give me negative 4, 0, all right. I can put a point, or I can just leave it like this. So I'll say that will be now 1, 4, 2. There must be a point here. Then 2, 6 like that. Okay. So I'll leave it like this as my answer. Okay. So I'll leave it like that as my answer. I don't know if you can try punching it. Then from there, what I'll do is, I'll say, this is my work, but work should not be reported. You can't have a negative work. So this, if it's a negative, just know that it was the system was what doing work. That's the meaning. But in actual sense, work will remain like that. Okay. 0.6 like that. So that there is a point. So this will be joule. All right. So now that we know that work is equals to P mg, or just mgh. All right. So that's the formula for work. So say work is equal to mgh. So we are looking for the mass. So say mass is equal, you divide throughout, that will be work over gh. All right. So mass is equal to, work is now 40142 point. So there is a point there, then 6, then over the gravity is 9.8. All right. Then open bracket. You can even include that negative and to cancel that. All right. Negative from there. But I won't put that. Mass can't have a negative as well. So some things you just have to use common sense. So what we do is, You multiply now, the height was 1. All right. So what would the mass? So when you punch on your calculator, I'm sure I should get something like um 40.9. Okay, 4096.94 like that kg. So that's the mass you needed. So you can just verify. I don't know with my calculator, it gave me something else. Again, I had calculated something else again. All right. So 0.26 divided by 9.8. 4096. Okay, it's still okay, but there's some missing things in the decimal thing. Okay, something missing, but you need to verify. If you just verify, you'll be able to get the correct answer. Thank you very much. So this is how you are supposed to solve this question. All right.